Thanks, everyone. Welcome. Uh, um, my name is Terrence Martin. I'll be serving as your moderator for today's webinar around from data silos to AI agents, building a scalable foundation for industrial autonomy. Before we get started and I pass it over to our speakers for today, just a couple of housekeeping items. First, we will be recording this session and sharing it with you all after the webinar. So if you have any questions or anything you wanted to kind of go back to, you'll have that in your inbox. We have a Q&A feature down at the bottom of our screen. Throughout this session, if you have any questions, go ahead and enter your question using that Q&A feature. And towards the end of our webinar, we'll go through some of those questions, get those answered. And if we don't have time to answer those questions, I'll be sure to follow up with you after the webinar as well. And with that, I'll pass it over to our speakers, starting with you. I'll pass to you, Knut.
Thank you, Terrence. Hello, everyone. My name is Knut Vidvei. I'm the head of industrial applications here at Cognite. And we're excited to share and present some real-world examples here from how AI agents is deployed in industrial frontrunners. And we have some great examples from you today. These cases are typically the hardest ones to solve, how to put AI agents into operations out of a proof of concept, but then into production and provide real value. And then the second hardest problem is then to move that at scale across multiple plants and multiple part of your operations. So we'll show some real world examples here with you today. So we will have examples that goes in these three categories. Number one is production decision support. That's going to be within manufacturing and look at some examples of debottlenecking some critical production processes. The second example here in the middle is going to be around process intelligence and how agents can investigate batch quality and things that run outside of quality specifications. And then last, we're joined with a real-world example from Idemitsu, where we'll look at data-driven maintenance, where we both look at how you can save tens of thousands of hours overall by using automation and AI agents in order to gather data and preparing for maintenance work. But first, we'll introduce the modern industrial data and AI stack that is needed to make all of this possible and to unlock the value we're talking about today. So I'm pleased to introduce my colleague, Justin Lawyer, to talk about what Atlas AI is so that we all have the same understanding before we dive into these customer examples.
Go ahead, Justin. Thank you, Knut. Looking forward to this journey today. If we jump to the next slide. So first of all, I wanted to, before Kubo-san shares Idemitsu's journey, I wanted to quickly explain what Atlas AI is and why it matters for industrial operations. So with that, we'll jump into some of the explanations. So first of all, as we're thinking about Cognite and our data platform, we really think about this as kind of a three-layer stack. At the bottom of the stack, the foundation is the industrial knowledge graph. This is where all of your contextual data about your plant and your operational processes resides, and it's connected to each other and it's ready to use. That is what empowers everything else. Atlas AI sits on top of that and provides agentic assistance and automation. Because it's built on the knowledge graph, it actually understands your plant and your operations and what's going on. It's not using generic training data, but your actual real operational content. And that's why it can be really valuable. And both of those pieces, both of those layers, power the industrial app experiences, whether that's web applications, mobile tools, or developer APIs. And so when you build with Atlas AI, you're not starting from scratch. You're building on a foundation of contextualized industrial data in the knowledge graph. So now really quickly, now that we've talked about what an agent is, or what the stack is, let's talk about what an agent is. An Atlas agent, it combines an LLM with instructions that you define for your specific use case on how to solve that problem. along with the tools that let the model take actions and direct access to your industrial knowledge graph so that you can get the data that you need in real time to help solve your problem. That last part is critical. It means the agent works with your actual contextualized data, your equipment, your processes, and the tools that you get access to from Cognite or specific tools that you are adding from your own particular workflows. And with that, we'd like to chat a little bit about Atlas AI itself. So Atlas AI does three things. First, it grounds your agents that you just created in your real operational data so you get insights specific to your plant, not generic answers. Second, it lets you rapidly deploy agentic workflows. We have templates for common industrial use cases, so you're not starting from scratch. That really speeds up your time to value and helps you get to good results faster for the problems that you care about. And third, it gives you tools to build and manage your own agents, whether you prefer low code or want full developer control through the APIs. Lets you manage your entire fleet of agents. This next slide here shows the breadth of data that your agents can access. Everything about your plant and operations that we contextualize into the knowledge graph. That can include sensor values, equipment hierarchies, 3D models, P&IDs, maintenance logs, work orders. All of it is securely grounded, meaning the agent respects your existing access controls and is fused together so we know which pieces of the graph are related together in terms of valves, pumps, electrical equipment, things like that. And then jumping to the next slide, one of the really important things that CDF provides is that speed matters. So we want to get you to value quickly. And so with Atlas AI, you can go from an idea to a deployed agent in days, not months. We provide templates for the most common industrial use cases, maintenance, root cause analysis, production support, things like that. So you can customize rather than build from scratch, and you can build your own unique ones as well and add them to the list of agents that work on your data. And as you scale, you'll have multiple agents, a fleet of agents. And Atlas gives you the tools to manage that, see what's deployed, monitor performance, upgrade models, upgrade prompts, upgrade the capabilities, and iterate and improve. And that's what we call agent ops, is managing the life cycle of those agents as you continually to improve them. And with that, that's Atlas AI in a nutshell. AI agents grounded in your industrial data, easy to deploy and built for scale. And now the best way to really understand this is to see it in practice. Kubo-san later from Idemitsu has been leading their Atlas AI journey, and she's later going to share what they've built, what they've learned, and what's working for their teams. But first, Knut will share a couple of real-world examples from pharma and manufacturing. Knut, over to you.
Thank you, Justin. So first, I want to get back to this example. This is a solution that has been deployed to our customers and in production on multiple plants. So I want to first give an example of how AI agents is used today inside of a modern data and AI stack, as we've seen Justin present to us. So the first example here is around production decision support and how we can do production optimizations with agents working alongside your people and your workers to increase their overall production. And the key here we're looking at an example is where you can go in and specifically remove bottlenecks and understand them through real-time production insights. And the background from all of these things is that in this specific examples, and it can be any critical manufacturing process, but we're specifically here also looking at things that are medicines that are in patent, which means that they might have a single company who can supply them. And it goes through multiple steps in a production process. If these are not produced on schedule, there are people who won't get their material or they won't get their medicines in time. So this is super important, and this is specifically on in-patent life-saving drugs. So what we're looking at here is working through live data on batches and using the agents to give you agentic insights throughout the entire production flow, surfacing the right information and data and to the user, And then there are humans in the loop who can then make those decisions, evaluations. So in this one place, typically this is either on a lot on paper or it is in data silos. But this solution then reaches across the different data silos, contextualize them, and give you the full overview of your batch manufacturing insights. And lets you focus on the right things like debottlenecking, lead times, yield, and production targets. So we've actually have a video here to also show a demo of what's going on. So here, make sure we have the full quality. We are here and I'm a production expert and I want to find out which operations are causing the biggest bottlenecks in my operation right now. So we start off with an agentic interface. The agent now goes in and looks across the different data silos and looks across the different production phases and now finds out across conditioning and the other steps, which ones are critical. And then if there are batches that are queuing up, and then evaluating the time we should be spending at each part of this batch analysis, and then checking it against historical data. And then you can ask follow questions. Can we start new batches this week? When will this finish? All of this data is readily available, and it can come in and then give you specific recommendations for what you should be looking into. So in the same UI here, go straight into the production flow. These insights come with you, and here you see an overview of all the different batches. So each of these equipments work in their own data bubbles in the underlying system because they are manual processes typically performed by humans, and they are in very isolated cells. And then there are buffer times between them. So through the different production steps here, there are manual steps. But here in this overview, you can then click on any part of it. It will pull the data from the underlying systems into the knowledge graph and then give you that. And here in every single step, you have agentic insights. So if you, for example, see a batch that is waiting too long in the buffer, the agent will gather all that information in the knowledge graph. And then the first line manager or the shift lead, for example, a human, comes in with the oversight and figure out what is going on. Is it a manning staffing problem? Is it a technical problem? And these different KPIs will guide you towards the best insights for that is. So the data that is typically you can't get an overview over is aggregated into this view. And then overall, the scheduling can then be contextualized. You can look at the average versus the actuals. And then all of the historic batches that you have is sort of also stored in the high performant storage that comes with the knowledge graph that lets you pull it up and immediately give you insights that you can act on. Another thing these agents can do is even do discrete event simulations. So it can then track how are we doing in case of production? How can I change my production? Can I do staffing changes to make sure I reach this week's targets? Can I schedule in a maintenance outage so that I know that this is coming up, so I should be planning for it earlier in the week or for next week? Or if I had an overrun on a specific batch last week, how is that going to impact my production this week? And here you even see advanced visualizations across the trends, which comparisons you should do, and then compare that to the daily throughput of the overall production. And this can be either looked at an aggregated level or drilled down to every single cell. If you have any questions or insights you want to have out of that example, please put it in the Q&A, and then we'll follow up with answers at the end of this webinar. So the second thing I want to talk about is then process intelligence. And the process intelligence is a great example of how we can use agentic insights as well in different parts of production. So here we are using it to drive advanced process analytics. And the overall target we're going after here is to reduce the investigation time. The previous example was to increase production and debottlenecking. Here we're looking at improving the overall process analytics. And here you can go in and analyze a complete batch genealogy using AI agents and visualize that in full. You visualize trends, you visualize the genealogy as you see here, and then you compare that to different set points that is set. When the batch quality is outside of that quality specification, it will trigger an investigation, and it should be within sort of 3 sigmas of that. So if any of these production parameters are outside of the regulated specification levels, you need to do an investigation of that batch. This is critical work, but it's also extremely time consuming. And this old adage of 80% of your time is spent looking for the data is qualitatively true in this event. So let's also look at a demo of what that looks like in practice. So here again, you start with an agentic interface. There's a batch that's outside of regulated specification levels, and a human triggers an investigation. And immediately it pulls up the genealogy of the batches, because these batches are producing not by one machine, but by multiple machines. And each one of these machines has their own variability, their own lab measurements, their own people working on it, their own sensor values. So here it's asking to see all of the batches produced by the raw material and show me the full genealogy. And it can then render this genealogy across multiple batches so that you can trace back. Because, as we said, since the batch, the produced result is across multiple production stages, and then you see the end result is out of spec, you have to go back and check each one of those steps to figure out what was out of spec where. So you manually have to go through this exercise. You have to go through your checklists, and you have to see if it's produced to spec, the right temperatures, the right manufacturing parameters. So the first thing we do here is that we break down the data silos. It uses the automatic contextualization that you find in the knowledge graph. So the agent has access to the right information it needs to do across all of these data sources. And if you didn't have that, you would have to manually go into the different source systems and pull this out. It's a very time-consuming process. The second thing it does is sort of like that checklist. It automates what needs to be done in the checklist that you have to do every single time we do an investigation. It does all the steps for you and creates a report that you can evaluate. And then the last and most crucial step is then the human evaluation and interpretation. The agent gives you the data, but the person can then go and check that against the data, make sure that everything is right, so that you also have a human in the loop. So what you've done is that you've taken the repetitive, time-consuming part of the job, and you've given that to an agent, and you've left the evaluation and the critical work that needs to be done by humans is then done and left over to these people. And these people are typically very capable, senior people with a lot of experience, and they shouldn't spend their whole day looking for data. They should be having agents that run in the background and pull up the right data for them, and then spend their time improving production, safety, and the quality of the things they are producing. So how is this even possible in a highly regulated environment? And I think that's a very important thing, because the agent does all the boring, time-consuming part, but the actual analysis, which you don't want to be different from each time to time, you want it to be the same analysis, same deterministic, that is done deterministically. And the second part is the agent can then have full confidence in it because there are no hallucinations here. It's running a deterministic analysis. And the tools accessing those tools are also deterministics. This is not a thing that you would like to use vector embeddings for those who know what that means. This is something where you want the actual agents to rather access tools in the knowledge graph that Justin was talking about. And inside CDF, we have these tools that you can run deterministic analysis or deterministic data capture and fetching, so that the agent just orchestrates it. And the last part, this is not just relevant for life sciences. This is any regulated or highly safety critical work across oil and gas, energy, other parts of manufacturing, and other industries as well, where you need agents to work together with humans. All right. And then same with here, if you have any questions about this process intelligence and how these agents work, please put it in the Q&A and we'll answer at the end. So then let's get over to Kubo-san and the Idemitsu intro. So I will just tee this up as the third one around maintenance and data-driven maintenance. So again, time-consuming work when you're doing maintenance is overall to gather the right information, creating work packages where you have work orders and sensor data, documents and backgrounds that you have to do manually each time. We've turned this from a 4 hour of manual work together with Idemitsu into just a few clicks, and then use AI agents to help you generate these work packages. There's a human review, and then it moves on to the next step in the maintenance process. So automating this work package assembly streamlines a lot of hours, and these things happens all the time. And they sum up to tens of thousands of hours across multiple sites for a larger company. We templatize this as an output in our industrial canvas, and then we use AI-powered insights in order to interrogate this data as well and then generate it. This not just saves time, it also increases the overall throughput and standardization. It enhances the overall health, safety, and environmental standards and the compliance, and it unlocks also the possibility to do reviews with AI agents. Jumping into the very specific task of just fetching the right data across data silos, the agent has been given tools and scoped what type of data it has access to. And then across this data set can go into tech manuals, technical documents, manuals, piping and instrumentation diagrams and process flow diagrams, handover and PIMS data. And the agent then have access to all of these things and can pull it together for a human to review before pulling it over. So with that, Kubo-san from Idemitsu Kosan will join us over here via video. Kubo-san is one of the key members in driving this Cognite implementation project at Idemitsu. And just to introduce the company as well, Idemitsu Kosan is Japan's second largest petroleum wholesaler. And they began implementing Cognite at 4 manufacturing plants 2 years ago, and they're now leveraging Atlas AI to enhance operational efficiency. So please pay attention to the use cases for these 2 AI agents, Tsukumo and Kuda.
Hello everyone, my name is Hanako Kubo from Idemitsu Kosan. Thank you very much for joining us today. I have been responsible for implementing CDF for about 3 years. In this session, I would like to share how Idemitsu, a company with over 100 years of history, is evolving toward the digital-driven future through our collaboration with Cognite and Atlas AI. It is intriguing how AI enables entirely new approaches that were not previously possible, and I'm delighted to share this learning with you today. Idemitsu Kosan is a global energy company operating across oil refining, petrochemicals, renewable energy, and mobility. Under our 2050 vision, Shaping Change, we aim to balance stable energy supply with the energy transition. I work in the manufacturing division, and I'm responsible for ensuring the safe and stable supply of energy. To achieve the energy transition, we are working on DX initiatives aligned with our 2030 vision, a responsible transformer. One of the key initiatives is the introduction of Cognite Data Fusion, or CDF. We position digital technologies not as supporting tools, but as a core engine for transformation. The goal of Idemitsu's digital strategy is to enable smarter, data-driven decision-making. As a first step, we began implementing CDF in 2024 as an integrated data foundation. Today, We are accelerating the development of Atlas AI by leveraging data that has been connected and contextualized within CDF. Beyond operational efficiency, our focus is on delivering tangible value that directly contribute to safer operation for operators and field workers. Now, let me introduce a real-world use case. Operators and maintenance engineers face several challenges. When incidents occurred, it was difficult to share lessons learned across similar processes or designs. Finding relevant past cases required extracting the right information, but descriptions of events and locations were often very specific to individuals. As a result, effective searches depended heavily on personal experience, leading to inconsistent answers and significant diagnoses. To address these challenges, we developed two AI agents, Tsukumo and Kudan, on top of CDF and Atlas AI. I really like these names and the characters. As a foundation for this, we brought together multiple data sources, including process history and data, maintenance records, engineering documents, operating manuals, and past incidents reports. With Atlas AI, users can ask questions in natural language and instantly receive practical, context-aware answers. First, let me introduce Tsukumo. Tsukumo is an AI application inspired by Japanese yokai. Its name comes from the belief that spirits live in long-cherished objects, and it represents an AI that helps preserve and pass on skills and know-how. With Tsukumo, users can search past incidents and operational knowledge using natural language. Even during live operations, it instantly brings up relevant procedures, technical documents, operational trends, and PNIDs. The queries don't have to be equipment specific. As a general purpose AI agent, Tsukumo helps operators quickly find the right information and reduce the risk of human error. Now, let me move on to Kudan. Kudan is an AI agent focused on performance and asset management. In Japanese folklore, Kudan is a yokai that is half cow and half human, and is said to predict the future. In our system, Kudan plays a similar role. It monitors observable signs of equipment deterioration and combines them with corrosion theory to advise users on what needs attention and care. Rather than simply showing time series data, Kudan identifies damage mechanisms, explains potential risks, and provides clear, actionable recommendations. This enables proactive maintenance and better operational decisions. By monitoring operational trends and reference datasets and applying analytical methods based on international standards, Kudan visualizes damage risks. Operators gain not only visibility into trends, but also a clear understanding of what kind of damage may occur and why. In this way, Kudan bridges the gap between real-world operational data and engineering theory, supporting better decision-making, especially for less experienced engineers. While quantitative impact is still difficult to measure, we are confident that these solutions function as living applications built on connected CDF data, directly supporting safe operations and high-quality decisions. Beyond efficiency gains of over 100,000 hours annually through data contextualization, we continue to make steady progress towards safer and more reliable plant operations. The key takeaway here is simple. Atlas AI makes complex industrial data easy to understand and use. Our journey continues. We have set the clear next steps for the next 2 years. This year, we will expand AI agent to more units across refineries and establish the company-wide standard platform for operational support. Next year, we will extend AI applications into adjacent areas such as production planning and quality, while building internal capabilities to scale both domain expertise and AI technologies. At the same time, data integration must continue, regardless of how rapidly AI use cases expand. Our ultimate goal is not simply operational efficiency. It is to build a knowledge foundation that underpins safe planned operations and enables safer, more reliable decision-making. Thank you for your time today. Let's keep moving forward together.
Thank you very much to Idemitsu Kosan for sharing very, very great examples. I also love how they have given their AI agents both name and character based on their traditions, especially the ability to look into the future. So today we've talked about what a modern data and AI stack looks like, what you need in order for you to both move agentic work process and industry into production, and also how you can scale it across multiple plants so you get actually return on investment on your investments in AI. There are more resources about how you can get high return on investments on cognite.com. We have independent analysis reports from Forrester that shows very, very high return on investments, over 400% ROI, and also that the payback time can be as little as 6 months. Then we've also been through 3 very specific examples of how AI agents has been used in the industry today. We looked at production decision support in manufacturing with debottlenecking of critical manufacturing process across data silos and manufacturing steps. We've looked at process intelligence, where agents can help you guide your way through a troubleshooting and investigation process according to a very strict checklists and analysis steps, with both including deterministic steps, so you have no hallucinations, and also what the role of the humans play in this role in the overall evaluation after you find out things are outside of bounds. And this last example here with Idemitsu Kosan, where we have agents helping you both in data-driven maintenance, and both on preparing for maintenance tasks and saving enormous amount of time, and also in the steps after, where you're also looking into the future and trying to have predictive. So the bottom line of all of this is not some crazy future. This is available today. And I hope you found value in seeing these examples and starting to see how you yourself can use agents in your company today, and how you can also get to the value that these forerunners have. So with that, I'd like to thank all of you, and then we move into Q&A.
Great. Thank you, guys. Thanks, Justin. Thanks, Knut. If you guys have questions, drop those in the Q&A section at the bottom of your screen. Looks like we have quite a few so far. Again, if we don't get to all of them, I'll be sure to follow up after the webinar. But first question we have is, excuse me, can I instruct Atlas AI agent to fetch extra context data from external REST API or SQL database? So that's first question. Second part of this question is, If that external data uses same identifiers or names for the asset objects, will this automatically contextualize agents' responses?
So I think maybe I can handle that one. For the first part of the question, we definitely support REST API and SQL queries to get additional information to put in the context of the agent if needed. Or alternately, it's often easier if that's a type of data that needs to be used constantly to go ahead and get that contextualized into the knowledge graph natively, and then make it easier for the agent to get it. But both of those methodologies work. If you're using a REST API or SQL query to fetch real-time data to add to the context, that is not put into the knowledge graph, but we do log your requests and the responses, so you can see for each one of your sessions what the responses were for audit purposes. Okay.
Awesome. Thank you. And then next question, where would solutions like Databricks or Snowflake fall in your architecture?
I can take a stab at this and you can follow up, Justin. So we have, as of last year, partnerships both with Databricks and Snowflake, and where we find that we get the best of both worlds when we fit it together into the overall architecture. So both Snowflake, Databricks, Fabric, and others, we're setting up what we call zero copy interfaces. Doesn't necessarily mean that there is zero copy of data between all of them, but that we standardize our interfaces and don't have to double store all the data into different staging areas. And we simplify the overall pipelines between the different systems so that you get the best of both worlds. The strength of Cognite is that we have our industrial knowledge graph that has a very rich graph-based description of all of your data and basically make all of your industrial data AI ready. That includes also then non-tabular data. So things that live well in tables, that's one thing. But you also have documents and the contents of the documents and diagrams. You have images and media. You have maintenance logs and rich data that are coming out of it, 3D models, 360 images. And all of these things together are coming together in the knowledge graph. But through the interface and collaboration with Databricks and Snowflake, we can also then integrate and point to data that is residing both ways. If you want to move, either you want to access the data in CDF from the Databricks side, or you want to do it from the CDF side. Anything you want to add there, Justin?
Yeah, I think in addition to that, many customers and people actually build machine learning models in Databricks or in Snowflake. And when they do that with those, they have a model endpoint so you can actually get requests or get the answers for your requests from their endpoints. And we have the ability to call those models from Cognite from the Atlas AI perspective. So we've got a way to really easily get the models integrated into your agents as a tool call. Okay.
Great, thank you. And maybe back over to you, Knut. I think this question might have come from the one of the use case videos or demos that you were showing. How do you define a batch in this example?
That comes down to the manufacturing process. So that's set up together with the customer defining on their definition of the batch. So if you see in the video, the different batches is set up and then they modeled through our data modeling service where we can describe the specific batches that is unique for your company. It's a very flexible but also standardized way of modeling the different batches. So that's all in the purview of whatever system that you have as your plants are set up in your batch analysis. Also because the manufacturing lines and processes also change over time. You need we have versionable models of these how the batches are, so you can version them and you can modify them and evolve them over time. So if you want to go deeper on that, feel free to reach out and then we can show you some real world examples of how we model batches and describe them and then how the life cycle of that data management can be done.
Anything on your end, Justin, you'd like to add or?
Nope, he did a great job.
Perfect. Okay, next question for either of you. How do you avoid hallucinations in knowledge graph with similar properties to answer a question? For example, oil rate can be obtained from back allocation, well test, simulation. How can the agent give me the answers that I'm looking for?
Maybe I can take this one. I think there's two parts to this question. The first is by contextualizing those different types of data that are very, very similar, appropriately in the data model, we can distinguish between the different types of, in this case, oil rates from back allocation, well test, and simulation in the knowledge graph, so we'll know which results we are getting and why. And the second part of that is when the agent is doing requests for the data and getting that, we link back to the actual source data in the knowledge graph, so you always know exactly where the data came from. And so if you want to, you can verify and make sure that that it's got the right data. And if it's not, then obviously you can go re-request and get the different data. But typically it's quite good by specifying it appropriately in the knowledge graph and then showing the contextualized data linking back to the source.
Yeah, I think it's important to us that in industry and engineering, and I'm an engineer myself, have worked in industries, that we provide the sources to those answers together with the thought process that it comes with. So if you are asking for an insight and something comes out of a document, we would link to the document and we'll have a hot link to the page of that document. So with one click, you open the right document that it used, it points you to the right page immediately. And then as an engineer or as a technical person or anyone, you can actually validate and verify that the agent went ahead and found the right thing. So addition to that, to Justin's setup there, a lot of context needs to be given, and that's why we emphasize the need for context in the knowledge graph, and that's why we use contextualization, is to make sure that the right data is linked together and it's sent up in a semantic way that the agents can understand it, because they are language models. So they don't only need access to data, they also need access to the context and the relationships and the semantics around that data. Great question.
Awesome, thank you. And this next question kind of sticks with that knowledge graph theme. How involved is knowledge graph built up, and how is it validated? Do you build this for a client?
I'm not really sure what is being asked in the question. How we set up and build and populate the knowledge graph?
That's that's what it looks like. But if for everyone out there, if you can clarify your question in there, but we'll go ahead, Knut.
No, I can give a general answer. So the knowledge graph that Cognite provides, first of all, it's kind of specialized for industry, and it comes with some building blocks that is already understands what you need to model. We call it the core data model, but it's basically just a set of building blocks, and we also then have different solution data models you can put on top of it. So in an overall knowledge graph, you will know what an asset is, and you can say this is a piece of equipment, and it comes with different properties, and you can describe through contextualization and data modeling how all of these things are connected. And we use a lot of automation and a lot of specialized tooling to connect all these different data together. So both we can model the data according to some industrial good best practices, and then make the relationships between that data obvious. We also then store high volume data like time series, sensor data, tags, or 3D models or files in specialized high performance, low latency storage. So when you ask for something like that, you ask the knowledge graph, but it'll pull it out of this high performance storage. When you want to go and implement something specific, maybe you want to do ISO standard or SHIFOS standard or another industrial standard where you want to then describe how that knowledge graph relates to your data. You can then do that on top of it with multiple data models that refer back to the overall knowledge graph. With this thing, you can also then have multiple disciplines within your company to model the data the way they see the world and according to the standards that's relevant to them. And then based on that, you extract the data, which means that we have then tools to map the knowledge graph to those standards. So it's, I think we also have resources on cognite.com and also our academy, where you can go in and really learn how to build and set up a knowledge graph for industry and with some very relevant, specific real world examples.
Awesome. Thanks, Knut. And this next one is around uh, I'll just read it word for word here. Do you have solutions for pressure vessels inspections, optimizations based on risk methodologies like risk-based inspection, API 581?
Now you're into very specific use cases. We have a wide variety of solutions that we've offered to customers all over the world. So for that one, I would suggest just get in contact with us and we can set up a session and we'll provide very specific examples of what we've done in that space.
Yep, awesome. And I think this is around another use case, so I'll ask it, but feel free to give a similar answer. But how does it work in continuous process plants? Any example of implementation of this for refinery or petchem industry?
Yes, and I would say we've probably done more in continuous process and process industries and petroleum chemistry, petchem, refineries, process plants, also continuous chemical process plants. We have several examples with continuous process examples here. Probably some of our more prominent ones are also featured on our website with customer testimonials within here. Refineries, like we have Idemitsu Kosan here. We also have other companies coming out there publicly around refineries. We also have process chemical process companies like Celanese, who are public references for us, where you can show specific examples. Also very, very forward-leaning on using AI agents, building their own solutions, but then powered by Cognite Data Fusion and Atlas AI. But then also, since Justin and his team has open standards on top of all of our AI solutions, those AI skills are also being put into their own internal solutions that they build themselves, or very specific skills that is being put into production and high-value process examples that we see. So typically around the process on production optimization, maintenance, turnaround planning, or workforce efficiency or digital operator rounds, and improving reliability through overall field operations. Those are the big examples that I can think of right now, and then there are public examples on our webpage.
Awesome. Thanks, Knut. We'll keep going. A couple more questions here. Why are vector embeddings not preferred? So I'm not sure who mentioned this, if it was you, Justin, or Knut, but either one of you can answer that.
Yeah, I'm happy to jump into that one. So we actually do use vector embeddings for vector search, for semantic search. One of the things to be thinking about is when you're working with data, it's important to pick the right tool for the right job. And knowledge graphs are amazing to understand the ontology of the data and how it's all related. And hey, I've got all these different documents and images and time series for this pump, and how does that work with the network of equipment that you've got in your production facility. What it doesn't do is similarity search in terms of figuring out, hey, what's the relative similarity of all these different things. And so if you really want to find specific phrases or specific topics in a policies and procedures document or repair manual or a work order, then we do semantic search to be able to find all of the related text, to find the exact quote within the document or within the work order to help you find that specific natural language piece within the data that is already in the knowledge graph. So we actually use both of these tools together, and we just make sure we're choosing the right tool for the right job. Knut, any comments or additions to that?
Yeah, a great question and answer by Justin, because I said that I didn't mean we don't use vector embeddings. We use it, of course. I was talking about in the specific case where you would need a fully deterministic, either data fetch or an analysis done. So sometimes when you're in regulated industries or you're in a very specific work procedure and you need to do a deterministic piece of analysis, for example, you would like to make that deterministic analysis. You declare that as a function or as a methodology that you want to run, and then you just allow the agent to access that deterministic analysis. And then that runs the same analysis exactly the same time, exactly the same way each time, which means you can make sure that the methodology that perhaps your company or that standard or that regulation says that you have to do. And in that sense, you don't want to use the vector embeddings for that, because those tools are great for the job that Justin highlighted. But if you want to run something that is very deterministic, that you need to have quality assured or version controlled methodology that you need to run each time, you set up that deterministic analysis, and then you rather have the agent call it every time. And that means that the agent is then given the guardrails and constrained not to do the interpretation. It only follows a work process of getting that data and insights to a human and running deterministic process that's part of your analysis. So it's more to make sure that you have that, or to show that it's possible to do deterministic calls in an agentic world if you set it up with tools that you can find with Cognite and Atlas.
Awesome. Great. And just time for maybe 2 or 3 more questions. But the next one I have here is, can you integrate Atlas AI to a pre-existing company AI ecosystem, i.e. Copilot?
Yeah, I'm happy to chat with that one. That's a common request. It's a great use case. We are an open platform, and we believe really strongly in interoperability between agents and also between tools. Sometimes you've got a tool that you need to reside on one of your servers, but we need to be able to call it externally. And so one of the great ways to do that is through MCP, and we're in the process of implementing that right now, to be able to call external tools and external models from Cognite and vice versa. And so if there are people that are interested in doing that, we'd love to chat with you to be one of our early dog fooders for that. So that's a really important case. We found that to be really, really useful and really helpful as we've been testing our systems with that right now.
Yeah, I will add that founding principle of Cognite is openness and data liberation, which means all of our APIs is open. They're open and open standards and available. So but of course, only securely only to you and who you give access to. The same goes with our agentic solutions. Again, you can both set them up with APIs and you can call them over APIs. And as Justin, we're expanding that to MCP servers. So you will find, partnering with Cognite, an open ecosystem that makes the best of the investments that you already have, and that plays into the overall ecosystem of AI solutions.
Great. And I'll stick with you, Knut, on this one. I think you mentioned something around zero copy. So this next question is, when will zero copy feature be available for Databricks and Snowflake?
So we're already working with Lighthouse customers on this. So then I would just say, be in touch with us and engage with our implementation and product teams on this, and sure we can move that along quite quickly. That's right now we're doing that on an engagement by engagement level and together in the partnership with Snowflake and Databricks.
Awesome. And then another use case question here is, do you have any other use cases of data-driven maintenance?
Yes, there are multiples. Let's see if I can pull them out. So, in data-driven maintenance, we talk a lot about the first part would be to make sure that you have the right scope. So what we've seen is that if you go into the different data silos if you're preparing for a shutdown, a campaign, or turnaround, or similar, or even routine maintenance, getting an overview is basically impossible. So what we do is that we pull the data out of the different sources, we contextualize them together with 3D data, 2D data, so diagrams, time-based data like Gantt charts, and we overlay the data on top of each other. So we the scope optimizations where you've perhaps already made a maintenance plan, and then we can show you visually either through the 3D in the 3D model or on top of 2D P&ID or process flow diagrams, where there are adjacent work that's happening maybe in a different timeline that should be including in your overall campaign, so you don't have to shut down the same place 2 weeks later or 2 months later. So avoiding shutdowns and then reducing the amount of downtime days you have. We also have use cases when you do overall scope optimization after that, improve the quality of your plans through collaboration with the field and visually. You have the work package generation that you saw an example of today and pulling in the right data and then automatically generating parts of this. Markups and preparation for a lot of them. And then the last step would be going out and actually doing maintenance execution, where you tie the field and office together, where a lot of this information is lost, especially when you're working with a lot of contractors and subcontractors, getting the right information out to the right people and then executing on that maintenance. I can go on and on about this and see if we can also get some more resources to you if you reach out after the webinar and then show you more specific examples.
Awesome. Anything you'd like to add to that, Justin, at all?
No, we just really appreciated taking the time to be able to meet with us. We're very interested in being able to help our customers really get to success. We love doing hackathons with our customers to help them get the use cases that they want up and running quickly. And we're interested in any comments or feedback that you might have. So we'd love to engage in a conversation.
Yeah, same sentiment for me. I'd also like to add that we launched at our Impact conference in October. We launched and are rolling out now our capabilities in building out these use cases faster and faster. So not just getting you to production and scale faster, but if you have some use cases or value you want to go after that is maybe more unique to you, or something that you haven't been able to solve today. We've engaged with customers and have stories where we solve that in days and weeks. Also with our new tools of building really fast building solutions and front ends and combining those with the agents you saw today. Some of the examples you saw today was the first versions was out in hours and days, and then over the next few weeks to production. And then we can iterate with you to getting it up scaled across all of your different plants and sites. So the speed of which development is happening right now is incredible. So if you are excited about that, I would love to get all of you in touch with us so that we can see if we can engage and then talk about doing this in a very short amount of time. This doesn't have to take years for you to implement and get return on investment. You can get it quite fast with the right engagement. So thank you everyone for joining. Really interesting questions. And especially thank you to Idemitsu for joining us and providing us with some great examples.
Yeah, absolutely. And with that, we'll conclude our webinar today. We will be sending out the recording over to you guys so you guys can look back and take a look at some of the talking points. And for those who still have questions out there, I'll be in touch to see if we can't get those answered or reach out to us directly. Thank you guys for joining. Thanks, Justin. Thanks, Canute. And again, a special shout out to Kubo-san and Idemitsu for helping us as well. And with that, thank you guys for joining, and we'll see you next time. Thanks, guys.
Bye.